Hello everyone, I am Bhavna. So let us see about IPv4 addressing. Firstly, let us see what is an IP address. An IP address is a unique address that identifies a device on the internet or a local network. IP stands for Internet Protocol, which is a set of rules governing the format of data sent via the internet or local network. IP addresses are expressed as a set of four numbers. An example address might be 120, 192.158.1.38. Each number in the set can range from 0 to 255. So the full IP addressing range goes from 0.0.0.0 to 255.255.255.255. IP addresses are not random. They are mathematically produced and allocated by Internet Assigned Numbers Authority, which is IANA, a division of the Internet Corporation for Assigned Numbers and Numbers, which is ICANN. Moving on, here are a few examples of the IP addresses shown here. Now, there are two versions of IP in use today, IPv4 and IPv6. The original IPv4 protocol is still used today on both the internet and many corporate networks. However, the IPv4 protocol only allowed for 2 power 32 addresses. This coupled with how addresses were allocated led to a situation where there would not be enough unique addresses for all the devices connected to the internet. IPv6 was developed by the Internet Engineering Task Force, which is IETE, and was formalized in 1998. This upgrade substantially increased the available address space and allowed for 2128 addresses. In addition, there were changes to improve the efficiency of IP packet headers, as well as improvements to routing the security. Moving on, let us see some points. IP addresses are binary numbers but are typically expressed in this decimal form IPv4 or hexadecimal form IPv6 to make reading and using them easier for humans. Let us see some IPv4 addresses points. IPv4 addresses are actually 32-bit binary numbers consisting of two sub-addresses identifiers mentioned above, which respectively identify the network and the host to the network with an imaginary boundaries separating the two. An IP address is as such generally shown as four octets of numbers from 0 to 255 represented in decimal form instead of binary form. For example, the addresses 168.212.226.204 represents the 32-bit binary number which is represented there. The binary number is important because that will be determine which class of network the IP address belongs to. Moving on. An IPv4 address is typically expressed in dotted decimal notation with every 8 bits octet represented by a number from 1 to 20 to 55, each separated by a dot. An example IPv4 addresses would look like this. IPv4 addresses are composed of two parts. The first numbers in the address specify the network, while the later numbers specify the specific host. A subnet mask specifies which part of an address in the network part and which part of addresses the specific host. A packet with a destination address that is not on the same network as the source addresses will be forwarded or routed to the appropriate network. Once on the correct network, the host part of the address determines which interface the packet gets delivered to. Moving on, let us see about subnet masks. A single IP address identifies both the network and the unique interface on the network. A subnet mask can also be written in dotted decimal notation and determines where the network part of an IP address ends and the host portion of the address begins. When expressed in binary, any bit set to 1 means the corresponding bit in the IP address is part of the network address. All the bits set to the 0 mark the corresponding bits in IP address as a part of the host address. The bits marking the subnet mask must be consecutive ones. Most subnet masks start with 255 and continue on until the network mask ends. Class C subnet mask would be 255.255.255.0. Moving on. Here are a few examples. So here are a few IP addresses classes which are shown here. So let us see a few more detailed information about the classes. So firstly, let us see about class A. In a class A network, the first 8 bits or the first dotted decimal is a network part of the addresses, with the remaining part of the address being the host part of the address. There are 128 possible class A addresses, which leads from 0.0.0.0 to 127.0.0.0. However, any address that begins with 127 is considered a loopback address. Example for a class A IP address 2.134.213.2. Moving on, let us see about class B. In class B network, the first 16 bits are the network part of the address. All class B networks have their first bit set to 1 and the second bit set to 0. In dotted decimal notation, that makes 128.0.0.0 to 191.255.0.0 as class B networks. There are 16,384 possible class B networks. Example for class B IP address is 135.58.24.17. Moving on, let us see about class C. In a class C network, the first two bits are set to 1 and the third bit is set to 0. That makes the first 24 bit of the addresses the network address and the remainder as the host address. Class C network addresses range from 192.0.0.0 to 223.255.255.0. There are over 2 million possible class C networks. So here we can see the example of the class A IP address, which is 198.168.178.1. Moving on, let us see about class C. Class C addresses are used for multicasting applications. Unlike the previous classes, the class D is not used for normal networking operations. Class D addresses have their first three bits set to 1 and their fourth bit set to 0. Class D addresses are 32-bit network addresses, meaning that they all values within the range of 224.0.0.0 to 239.255.255.255 are used to uniquely identify multicast groups. There are no host addresses within the class D address space since all the hosts within a group share the group's IP address for receiver purposes. Example of class D IP address is given here, which is 227.21.6.173. Moving on, let us see about class C. Class E networks are defined by having the first four network addresses bit as 1. That encompasses address from 240.0.0 to 255.255.255.255. While this class is reserved, its usage was never defined. As a result, most network implementations discard these addresses as illegal or undefined. The exception is 255.255.255.255, which is used as broadcast addresses. Example for Class E IP address is 250, 243.164.89.28. Moving on, let us see some private addresses. Within the address space, certain networks are reserved for private networks. Packets from these networks are not routed across the public internet. This provides a way for private networks to use internal IP addresses without interfering with other networks. The private networks are given here, which are the examples. Let me just show you the first one. 10.0.0.1 to 10.255.255.255, and this the other two in the similar way. Moving on, let us see about the special addresses. Certain IPv4 addresses are set aside for specific uses. So here we can see the IPv4 addresses which is specifically used. Here 127.0.0.0 is loopback address, which is a host owned interface, and 224.0.0.0 is IP multicast, and 255.255.255.255 is broadcast, which is sent to all interfaces on the internet network. So this is all about special IPv4 addressing. So this is all about IPv4 addresses. I hope you all understand. Thank you.